All right, hello geometry students. Here we are with our last lesson of chapter 4, 4.6, CPCTC, which what on earth does that stand for? It's a pretty long acronym, and it stands for our one and only definition for this lesson, and that is corresponding parts of congruent triangles are congruent. Okay, let me say that again for each letter. Corresponding parts of congruent triangles are congruent. Okay? And so what this basically means is that if you prove triangles congruent, you then know that all of their corresponding parts are also congruent. Up until this time, we've been doing it this way. We've basically been proving the parts, angles and sides, to prove the triangles. What this basically says is if you know the triangles are congruent, let me clarify that congruent parts means congruent triangles, but it also means that if you have congruent triangles, that can also prove congruent parts. Okay, so let me give you an example. Say we know we have here that triangle GHI is congruent with triangle JKL. First of all, let me go ahead and just draw those out. We'll draw them something like this. All right, we got G, H, and I, and J, K, and L. And so if we know from the beginning that those triangles are congruent, then I know all their corresponding parts are congruent. Okay, corresponding parts, we've covered that. That means basically that like angle G and angle J, they correspond to each other. They're both the first letter, and we can see it visually. They're the same angle. So we would know then that angle G is congruent with angle J. Or for example, I know that this side here, HI, must be congruent with its corresponding part, KL. So I know that HI is congruent to KL. All right. And so it's a reasoning so that if you prove triangles congruent, then you know that all their other parts are congruent. Because for example, we learned that you only need 3 pieces of evidence to prove a triangle congruent. So let me just erase this for a second. So say we prove these 2 triangles. They didn't just give it to us, but we proved it like this. We said, okay, we knew GH and JK. We knew angle G and angle J. And we knew GI and JL. So say they had proven this with side angle side, right? I would know the triangles are congruent. Then what if they came along and they said, well, what about HI and KL? You used the other 3 sides to prove them congruent. Do you know, therefore, that HI and KL are congruent? And again, according to CPCTC, corresponding parts of congruent triangles are also congruent. That's how we would then know something like, we'd know something like this. So say you knew the 3 that I've listed, but you would know that HI was congruent with KL. You would also know that angle I is congruent with angle L. And you would also know that, let's see, what's the other missing? You would know that angle K, which corresponds to angle H, is congruent to angle H. So all CPCTC means is that once you know the triangles are congruent, you get to assume or logically conclude that all the other corresponding parts are also congruent. Okay, talked about that a long time, trying to get a better feel. Let's look at the questions and flesh this out just a little bit more. 3 questions, including a practice proof. So number 1 says, if you can prove 2 triangles congruent, what does that mean about all the other parts? Okay, like to hammer it home, right? If you can conclude that these 2 triangles are congruent, then all corresponding parts, that always means not every side is equal to every other angle, but all corresponding sides and angles are also congruent. Okay, so let me just use a similar example. Say that we proved these were congruent with side, side, side. Okay, side, side, side. So I know that 3 of the sides are all congruent, and so I know the triangles are congruent. Well, what else can I conclude from that? Well, that also means all the other parts that we haven't talked about. In this case, the angles, all three angles are also congruent. Okay, so in other words, angle B must be congruent to angle E, angle A is congruent to angle D, and angle C is congruent to angle F. Okay, so again, number one, if you can prove two triangles congruent, then all the other parts must be congruent. Okay, all right, let's look at number two. Number two asks, if you see that a proof wants you to prove a pair of sides and angles congruent rather than the triangles, what is your final step of your proof, most likely? Okay, so here's an example. So I have these two triangles, and again, I've proved, it says to prove, I can see, oh wow, I can prove these congruent, SSS, that's easy. But look at the prove. The prove actually says, don't prove the two triangles congruent. You'll get proofs where the final proof is a certain angle or side, in this case, angle T and angle X. And the point behind this question is, up until this time, your last reasoning was always what I call the finishing move, SAS, SSS, AAS, etc. But now you're going to get proofs where the final proof is an angle or a side. What I want to point out is whenever that's the case, your strategy is this. Prove the triangles congruent. Whoops. Prove the triangles congruent, then use CP/CTC to prove the remaining parts. So now what strategy, sorry that my picture is kind of in the way, let's see if I can move it. The strategy is prove the triangles congruent like you always would, and then whatever part they said to prove, then you can just prove that using CP/CTC. So in other words, the shorter answer to this question is that your final what does it say? Your final step. The final step would be something like this. If I knew these three triangles, STU and WXY, were congruent, my final step would be that angle T is congruent to angle X by CP/CTC. So if the proof of a proof is not the whole triangles, but a part of the triangle, your final step is probably going to be CP/CTC, because you're going to have proved the triangles congruent. In this example I've given you, SSS, then you would say, so therefore, because these entire triangles are congruent, then angle T must be congruent to angle X, because corresponding parts of congruent triangles are congruent. Okay, and so let's go ahead and try number three now as an example of this. Though I'll already admit slightly more complicated than even the what I was talking about previously. So this is page 263, number 4, or was it number 4? Yes, that's correct. So let's see, we got a given. Given AC is congruent to AD, CB is congruent to DB, and I need to prove that AB bisects angle CAD. So right there, you want to go, whoa, this is different than anything I've ever seen. The proof is not ABC is congruent to ABD. That would be a standard proof. This is, oh my gosh, I'm going to have to prove this right here. That's unusual. Well, all I'm going to say is that implies, as soon as you see that, you know at the end, you're probably going to be using this. Okay, but first, we're still going to do everything we've already learned. The first goal is just to prove the triangle is congruent. So let's start there, and I'll show you how you use this final step. So where do we start a proof? I always recommend start with the given. This one's not too complicated. AC is congruent to AD. I'm going to mark that on my drawing, AC, AD. How did I know that? It was just straight up given to me. Praise him. Okay, then I also know that CB, side CB, is congruent to side DB. So that's, what is that, CB right here, right there. So those are also congruent, and that was also given to me. Hey, it's a giveaway. So easy. All right, so now I have two sides. I need one more piece of information to prove the triangle's congruent. And you can see there's our visual clue. We've got this common line AB across the middle right here. So that means that, like I said, this is an easy proof, at least to start. I know that AB is congruent to AB. How did I know that? It's the same line, so we call that reflexive. Okay, reflexive property of equality. So now I've got my three pieces of information. It's not AAA or ASS. And so I can say triangle ABC is congruent to triangle ABD. How did I prove it? SSS. Okay, now in a normal proof, I'd be done. Hey, look, I usually have been up to this point proving triangles congruent. Here we go. But now I'm actually have to prove that line AB bisects angle C, let's see, angle CAD. So I'm talking about this angle right here. Okay, so how do I know that this angle is being bisected? Well, here's the new trick. Because the entire triangles are congruent, then I know that all their corresponding parts are congruent, and that includes this angle here and this angle here. They must be equal because I've already proven the triangles are congruent. So therefore, I know that, let's see, that angle is CAB and DAB. So I know that angle CAB is congruent to angle DAB. How did I know that? My friend. CPCTC. Because once I've proven, so I still do my normal proof, once I've proven the triangle is congruent, SSS, then I know that all the corresponding parts of the triangle must also be congruent. Okay? So that's why, again, it comes even after the finishing moves we've learned up to this point. Then we actually have to go a step further. A simpler 4.6 proof will actually stop right there. This one said, now it actually goes all the way back to a hint. In other words, because those are congruent to each other, that means that this line AB, whoops, highlighting it, this line AB must be bisecting angle CAD. Okay, so therefore I know that I can say that line AB must bisect angle CAD. Is that right? Did I name it right? Yeah, CAD. Okay, and how do I know that? I know that by definition. Whoops. Same reason we do it in reverse. Definition of an angle bisector. If each angle is congruent on either side, then that line must be bisecting it in half. So there you have it. What CPCTC means is we can add a little bit of extra proof. Once we've proven the triangles, we can therefore back up and prove that all the corresponding parts are congruent, and then therefore that would even allow us to prove that that line must be a bisector. Okay, so this is probably about as complicated in terms of length of proof you will find. Again, the first three steps were fairly easy, but this is an example of how CPCTC allows you to go a little bit further. So I encourage you to review that, and we'll be working on this in class, and if you give it your best, you're going to do really great. All right, take care, and see you soon.